Thank you. Thank you, great students, and hope you're good and feel welcome so that we can go through this particular area. I want to major on polygons, where I want us to I'm providing a question, then we are going to use this particular question to try and understand this particular concept and how to work questions related to this one. So a heptagon, that is the question. A heptagon has two of its interior angles as 155 degrees and 165 degrees. Now the remaining angles are equal. So find the size of one of the equal interior angle. So an heptagon has two of its interior angle as 155 and 165 degrees respectively. The remaining angles are equal. So find the size of one of the equal angles. Now I'm providing the discussion, but I'm going to approach this question using two approach. The first one will be called alternative one, where we all know that interior angles in a regular polygon is actually given, that sum of interior angles is given by n minus 2 multiplied by 180. So if this is the particular sum of the interior angle, then we can sum up the interior angle and then equate to this one. And therefore we are going to have n minus 2 into 180 degrees is equals to the first interior angle is 155 plus the second interior angle, which is 165. But because we have taken 2, then we take n minus 2 because we have already the two interiors angle here. So we are going to have n minus 2 multiplied by the number or multiplied by the size of the remaining interior angle, which is x. And by so doing, expanding this one and also recalling that n is 7, we can easily get the value of x, which is the missing interior angle. And therefore, we are going to apply this. I'll substitute in 7 where n is, and then I'll expand it, and then simplify. So 7 minus 2 is 5. Then if you multiply by 180, you're getting 900. Similarly, 155 plus 165 is 320. Then plus 7 minus 2 is 5 multiplied by x, which we get 5x. Now this implies that if I take this 320 to the other side, then I divide both sides by 5, then I remain with x is equal to, or the remaining interior angle is actually 116 degrees. Note this one that a heptagon in most cases has 7 sides. That is a 7-side polygon. Now alternative B, we can actually approach this particular equation by use of exterior approach. That is exterior angle approach. Here, we already know that the sum of exterior angles add up to 180, not 180, rather than add up to 360. That is the sum of exterior angles add up to 360. So this one in mind, then we are given the first interior angles as 165. Also, we know that interior angle plus exterior angle give us 180. So to get the exterior angle, we'll take 180 minus the interior. So 180 minus 165 plus 180 minus 155, then plus n minus 2. Remember, the two exterior angles are here. Then I'll say n minus 2, the one that we have added, multiplied by the exterior angle that we don't know for that case. Now, recalling that n equals to 7 because it's a heptagon, then the y, which is the angle of the exterior that we need to find, is going to be gotten by substituting n equals to 7 and simplifying. So we are going to have 360 equals to 25, that is 180 minus 165, which you get 15, and 180 minus 155, which you get 25. Now summing these two, we get 40. Now getting 40, then as 7 minus 2 times y, we get 5y. Now taking this 40 to the other side, we remain with 320. Then dividing both sides by 5, we remain with the exterior angle being 64. So the missing exterior angle is 64. But because the question requires that we find the interior angle, then we recall that exterior plus interior angles sum to 180 degrees. If we know this is the case, then it tells you that interior angles is equals to 180 minus the exterior. Remember, we have already gotten the exterior. So we'll have 180 minus 64, the one that you've gotten. And if you see that one, that is the interior angle is equals to 180 minus 64, which gives us 116. So you see, if we can relate these two, that is, we can either relate the sum of interior angle to the sum of the interior angles that are given, and then you try to find that value of n, or the value of the angle that is missing. Or alternatively, you can use this exterior angle approach, where you convert those particular angle to their respective exterior angle, and then you try and find that particular angle that is missing. I believe that short demonstration is actually necessary, and also has enabled you to understand that particular area of polygon. Remember to be part of my class by subscribing, so that you can be notified whenever a new video is uploaded. I appreciate and thank you for your time.